All right. So this unit, what we're about to start before Christmas, and we will test it before Christmas so that we don't have anything going into Christmas break. I will say, I don't like saying stuff like this, but I think it bears saying. This is probably the most difficult unit in Math 10. Okay? Now, it's difficult because students usually, I'm not saying all of you, but some of you, tend to just let things slide and try to learn it the night before. You cannot do that in this unit. You will get run over on the test. Okay? So you need to do everything I ask you to do as we go through it. Every day when we start questions on the board, please do the questions on the board. If you don't understand something, please come in to clear it up right away, because this one is, like I said, probably the most difficult in terms of like test scores. When I look at test scores, this unit would be a little on the lower side. But also moving into grade 10 and 11, or sorry, you're in grade 10. Grade 11 and grade 12, this stuff becomes more and more important. It's assumed that you know all this stuff, okay? So what we're going to do is we're going to move away from when we graph things. This whole unit's about graphing, but graphing straight lines. We don't graph nonlinear lines in grade 10. But not using tables of values to graph it. Just using the equation, marking a couple points, and sketching the graph, okay? So having said that, and we've talked a bit about this, how do you know if something is linear? Looking at the formula, how do you know if something's linear? The exponent is 1. So looking at the first one, is it a linear or nonlinear graph? This is linear. Whoops. And we know that linear is a straight line, basically. I'll sketch all these. I don't expect you to know all the ones that are not linear, but I'll just sketch them just because. What about the next one? Is it linear or nonlinear? Linear, because the exponent is 1. This one looks like that.
How do we know that?
Well, we're going to get to that.
Okay. No.
What about the next one? Linear or non? Non-linear, and that one looks like this.
Oh.
Because I know what the equations are. And that's the point, is when you get into the higher grades, you'll be able to look at the equation and know what the graph, a general shape of the graph. What about the next one? Non-linear. What type of shape is that, though? It's a parabola. It's the U shape. It's the U shape. All right. What about this one? 1 over x. Linear or non-linear?
Linear. There's no exponent for 1.
Is that the same thing? It is the same thing. So is it linear or non-linear? It's non-linear. And it looks like this. You ready for this? That red line going up the middle is an undefined point called an asymptote, that if you take Math 12 and beyond, you will learn about those. But that's Math 12. All right, next one. Linear or non-linear?
It's not linear because it's going to be a negative exponent, right?
What's the exponent? It's just 1. What about the next one? Linear. And what about the final one? Non-linear, because x can be anything.
How do we know that it's not? You're guessing, because we don't know if it's right or not.
He just actually doesn't know.
He doesn't know at all.
I don't know. I'm just randomly guessing at these things.
Actually, it looks like this.
If you just say it with confidence, then everybody will believe you. These are all the correct shapes of the graphs. It's not?
I'm sure.
prove it, plug them into Desmos if you want. I will tell you the numbers here. That's 1. That's 3. Whoops. That's 1. That's -3. This is -2. That's 0. And that'll be 1. But excluding the last one, what do you notice about what do you call this number? Okay, it is a constant, that is true. But is it the x or the y-intercept? That's the y-intercept, right? 1, 3, 1, -3. What's your y-intercept here? 0, -2, and that one is that one. All right, so what do all these numbers correspond to in the equation? It's the constant term. All right, the term that doesn't have a variable. This one would be +0. So that's your first clue, is when you put, so what's the x value at the y-intercept? 0. So when you put 0 into these equations, that disappears and you're left with just the y-intercept of 1, 3, 1, -3, -2, and 0. That's how I know the y-intercept part. Okay? That's a math 12 graph, that's a math 11 graph, that's a math 12 graph, and that's a grade 12 graph. Everything else is linear. So let's just look at the linears. Looking at the slopes, which ones have a negative slope? Second one.
Third one.
Third one? This one?
No, at the top.
No, I'm just looking at the linears.
Oh.
So just the second one, right? That's a negative slope. Does everybody agree? Because it's sloping this way, you read it left to right, it's going downhill. So that's a positive slope, that's a positive slope, that's a positive slope. What do you notice about the number in front of the x here? It's negative.
So that's how you know.
So what does this number represent? It represents the slope, right? That's a -2 slope. That's how I knew what the graph looks like. Okay, this is a +3, so it's a positive slope. That's slope of 1/2, so it's going to be less, but it's still going up. And that's slope of 4. Boom. That leads us to the next page, which is a linear equation is anything in the form y is equal to mx plus b. This is also known as the slope y-intercept equation. Why do you think it's called slope and y-intercept? What pieces of information did it give you on this page? What's this number? Y-intercept. What's this number? The slope. That's why it's called slope and y-intercept. All right? Slope, if you remember, is m. B, the constant number, they just give it the letter B, is the y-intercept. All right. Is that okay? Okay. Let's go to the next page. We're going to skip that. We might come back to it, depending. The bottom of the next page. So, 3 equations. I want to know, first of all, if they are linear. Are these lines linear? They are, because the exponent on the x is 1 on every single one. Okay. So now I want to know the slope and the y-intercept. From the first one, remember the equation is this, mx plus b. The number in front of the x is your slope. The constant term, or the number without a variable, is your y-intercept. So what's my slope? What? 3 over 1, the number in front of the x. You can write 3, but 3 over 1 is a little easier because when we start graphing them, it's rise over run. What's my y-intercept, or b value? Positive 2. That's it. What about b? What's my slope? Take the sign that's in front of the number. So it's negative 2 over 3. What's the y-intercept? 7. All right, what's wrong with the next one? What, sorry? There's a 6 in front, so what do I have to do? Divide off the 6. Divide everything by 6, because we want y equals. So I get y is equal to 8 over 6x plus 1 over 6. Now, 8 over 6, can I reduce that? Is there a number that goes into 8 and 6? 2. What goes into, how many times does 2 go into 8? How many times does 2 go into 6? So it's 4/3 x plus 1/6. All right, that's the equation. What's m? What's b? What's your slope? 4 over 3. And what's your b value? 1 over 6. All right, we're almost done. Okay, everybody go to assignment question 3 on page 393. Right here. We're just going to do the first one together just because it's a little different. So, number 3 says, write the equation of each line with given slope and y-intercept. This is your equation. Again, I won't ask you to memorize it. I will give it to you, but we're going to use it so often you should know it anyway. We'll just do A together. Write the equation of each line. So, my slope is 4. That's M. My y-intercept is -9. That's B. So the equation of a line with a slope of 4 and a y-intercept of -9 is 4x minus 9. You just plug it in for M and B. That's it. Is that okay? M represents your slope. B represents the y-intercept. Sorry? Yeah, but it means the y-intercept on the graph. So. But yeah, it's the constant term. Yeah. Yes.
No, I'm not gonna ask.
Okay. All right. I would like you to do numbers 1, 2, 3, and 1, 2, 3. That's it. Please. Those ones. Boom. Okay, you get the equation 2x minus 5. Y is equal to 2x minus 5. First thing you ask yourself, is it linear or nonlinear? It is linear. So then you figure out your slope and your y-intercept. What is your slope? 2. I'm going to write it as 2 over 1. Okay? Just because that makes a little more sense the way we're going to do it. And what's the y-intercept? -5. So when you're going to graph it, you mark the y-intercept on the graph, -5. And then using your slope is what over what? It's rise over the run. So if our rise is 2, from that y-intercept, you count up 2, and the run is 1, both positive. There's your second point. All right? You only need 2 points to draw a straight line. So you could just graph it from this, but if I wanted to test another point, I would go up 2 and over 1. And I keep doing this, up 2, over 1. And you can keep going. But then you're just going to draw a line. Ideally, use a ruler. But there's your graph. And you'd put arrows on the end of it because it can go on forever in both directions. So that is the graph of 2x minus 5.
That's what I did on this.
Perfect. Good. Okay. We're not going to verify using a graphing calculator. We don't need to. All right. There is another way to do it using the equation of the line. Y is equal to 2/3 x. So we're doing a different one. Y-intercept is what? -6. So B is -6. What is the x-intercept? How do you find the x-intercept of a graph? Yeah, but what's the value of y at the x-intercept? 0. So that means y is 0. So if you put y is equal to 0 in here, I get that. I'm going to move the -6 over. So add 6, add 6. So I get that. How do you solve for x here? This is good algebra practice. What am I going to do? You can divide by 2 over 3 or multiply the 3 up. What's 6 times 3? 18 equals 2x. How do I get rid of the 2?
Question, would you get the same answer if you did like divide by 2 over 3?
Yep, do it on your calculator.
It would just take a really long time.
Well, no, you do this. If you did it your way, so you want to go, you don't have to write this down. So you want to divide off the 2/3. That's proper. So you divide this side by 2/3. When you're dividing by a fraction, what do? Flip the denominator and multiply. So this becomes 6 times 3 over 2. What's 6 times 3? 18. Divided by 2 is 9. So you get the same thing. All right. So we have our y-intercept of -6, which is right there. We have our x-intercept of +9, which is right there. So now you can just connect them in a line. All right. Look, there's only certain cases you're going to want to do it this way. I would say if I gave you this question on a test, I would just say mark the y-intercept, -6, that's fine. But then my slope, what's my slope here? It's 2 over 3, right? So from that point, you'd go up 2 and over 1, 2, 3. If I drew my line properly, you'd be right there. Up 2 over 1, 2, 3. Up 2 over 1, whoops. Over, up 2 over 1, 2, 3. So you get to the same thing. All right? It's easier if you just mark slope and y-intercept. That's how I did it so fast, yes. So I wasn't just lying.
I did check on that one.
Did you? Really?
Yeah.
You didn't trust me?
No, I didn't at all.
Wow. Okay. That hurts, but that's okay. All right, so if you get an equation, mark the y-intercept, use the slope starting from that point, and use the rise over the run and count to get enough points that you can draw the line. Okay? Numbers 4, 5, 10, 11, and 12, please. They won't take that long. They're just pretty quick.